Good morning, students. Today is going to be the 30th session and this is going to be the last part in the third unit, crystal field theory. So in today's class, we are going to deal with John-Teller distortion in square planar coordination. Concerning to the square planar coordination, we are going to study the John-Teller distortion. So John-Teller distortion in square planar coordination. So according to John-Teller distortion, if the ground electronic configuration of a nonlinear complex is orbitally degenerate, the complex will distort so as to remove the degeneracy and achieve a lower energy. According to John-Teller distortion, if the ground electronic configuration of a nonlinear complex is orbitally degenerate, the complex will distort so as to remove the degeneracy and achieve lower energy. The removal of two ligands on the z-axis of an octahedron results in the formation of a square planar complex. So when I am going to remove two ligands from an octahedral one, it is going to lead to the formation of a square planar complex, and this is what we are going to study in today's class, that is John-Teller distortion. For example, if the original complex is going to be an octahedral, if the original complex is going to be an octahedral and it is going to be, the complex is of D8 configuration, the 6 electrons are going to be occupied in the T2G and 1 electron each in the EG orbitals. This arrangement is same as in the case of weak field, because here the electrons are not going to be paired up. The orbitals are symmetrically filled and this is going to have a regular octahedral complex is going to be formed. Now, what happens if it is going to be a D8 configuration? Let us see two examples under this, that is in case of hexa-aqua nickel 2 and hexa-ammonia nickel 2. In this case, what happens is, here ammonia and water molecules are going to be of different types of ligands, that is the splitting caused by them is going to be different. The single electron in dx² minus y² orbital is being repelled by the 4 ligands, while the electron in the dz² orbital is only being repelled by the 2 orbitals. So here what do we observe is, in case of the electron present in dx² minus y², this is going to be repelled by 4 ligands, while the electron present in dz² is going to be repelled by only 2 ligands. Thus, the energy in dx² minus y² is going to increase relative to the dz². If the ligand is sufficiently strong, the difference in energy between these two orbitals becomes larger and the energy needed to pair up the electrons. Under these conditions, a more stable arrangement arises. Because of this difference in energy, what happens is, a more stable arrangement arises when both the EG electrons pair up. Here, the electron which was present in 1 in dx² minus y² and dz² are going to pair up and occupy the lower dz². This leaves dx² minus y² orbital empty. Thus, the 4 ligands now approach along the plus x, plus y, minus y without any difficulty, as dx² minus y² is going to be empty. However, the ligands approaching along plus z and minus z directions meet very strong repulsive forces from the dz² orbital. Thus, only 4 ligands succeed in bonding to the metal. This gives rise to a square planar complex is formed. The attempt to form an octahedral complex is going to become unsuccessful. In case of examples of square planar complexes are copper 2, nickel 2, cobalt 2, nickel 2, copper 2. They also have a square planar complex. The amount of tetragonal distortion that occurs depends on the particular metal ion. It depends upon the metal ion and the ligands. Sometimes the tetragonal distortion may become so large that the dz square orbital is lower in energy than even the dxy orbitals. It is going to be shown in square planar. Dz square is going to have a lower energy. Square planar complexes are usually formed by D8 ions with strong field ligands. So if it is going to be a strong field ligand, the electrons are going to be paired up and they are going to be present in the dz square. They are going to be present in the dz square, making the dx square minus y square empty. And so a square planar complex is going to arrange. Square planar complexes are formed by D8 ions with strong field ligands. But they also arise in D4 ions in a weak field ligand. In this case, dz square contain only one electron. In a weak field ligand, dz square is going to contain only one electron. So, in today's class, we had studied upon John-Teller distortion in case of square planar complexes. So, John-Teller distortion states that if the ligands are going to approach in an non-linear equally, then the degeneracy is going to be disturbed. Thank you, students.